guys, today we are doing a very popular question. It's called flood fill. It's basically a simple depth first search problem. Here we have been given an API signature already, flood fill, which takes a matrix called image. It takes the starting coordinates, it takes the new color. So what we need to do here is actually basically something very similar to replacing a color, right? So let's say we have adjacent colors which are same. So for example, here we have this matrix. Let me just put it here so it's a little bit more visualized. So let's see, and here, right? So let's say we are given coordinates this, right? Now we can see that everything adjacent is the same color except diagonally. So we are not going diagonally, we are just going up, down, left, right. Now as you can see, we are given a starting point. We need to identify what color that is and identify all the adjacent neighbors using up, down, left, right, 4 directions, and replace them with the new color, whatever that is, right? So in this case it was 2, so we just went ahead and replaced everything with 2 except the fact that diagonally is not pressed, right? So if we were to replace, let's say 0, we would only replace 0 with, let's say, new color 2, right? Because there is nothing up, down, left, right, and here it's diagonal, so we don't change it. Anyway, so I guess that's clear. If not, please let me know in the comment section. Right, so what we are planning to do is we build a helper method here where we would recursively find all the neighbors and mark them with new color. That way we can just do this in place within this two-dimensional array and return the image to the array at the end once we are done. So the time complexity for this one would be a linear time, and the space complexity would be no extra space here, right? We are not going to need any extra space. Alright, so let's get started. So like I said, we need a helper method here where we can do this recursively. Alright, so let's see. So let's define a method. Define recursive flood fill, right? And it takes an image, it takes the starting and ending point, it takes the current color that we are trying to replace, and it also takes the new color which we want to replace. Alright, so before we get to this method, let's come here. We will obviously call this method from here, and here starting and ending points are defined like this. See, current color would be whatever is on that image at given coordinates, right? Given starting coordinates, and the new color we already know it could be anything. Now before then at the end we would just return the image. Now here we want to make sure some sanity check is done here. So let's define a method called is within bounds, right, where we would take starting coordinates along with the actual matrix, and if it's not within bounds, then we would return let's say an image itself, or maybe -1, depending on whatever they want. Else we would come here and return the image. Alright, so let's define this method, right? Probably it's going to be a class method, right? So this is going to be pretty simple. Let me just make this I and j so it's very generic, and name this as a grid. So all we want to do is if I is going out of bound, it's exceeding the actual length, or if it's going negative, and same is true for j. or j is exceeding length of columns, so hence 0, or j is less than 0, which is negative, then this is going out of bounds, so we will mark this return false, else we will return true. That's pretty simple, right guys? Now let's see if here what we are going to do is we would define our base case where we'd say, hey, if are we within bounds, if we are within bounds, if we are not within bounds, right, then we want to return. Now else we want to recurse here, so the way we are going to recurse is in 4 directions, right? So let's see, j, now let's see, we want to recurse in 4 directions. In the row below, row above, on the right hand side, on the left hand side of the current cell, right? So these are the 4 directions we are going to recurse, and once we are done, we are going to return from here. Now we want to make sure that we do not visit the nodes which we are not interested in. For example, we are only worried about replacing the color if the color is the matching with the current color, right? So if it's 2 and if it's 1 and if it's 1 around it, then we want to go ahead and replace it, right? So and if it's something else, like for example 0, we want to skip it. We don't want to visit that node again. So let's see, let's check if the color that we are seeing is something that we are not planning to replace, right? So we want to return. Or if color that we are at right now, if it's already been replaced, then we want to skip, right? And if it hasn't been replaced, then we want to mark it as new color. That way we do not color it again. All right, so okay, I think that is it, guys. Let's see. This is very simple DFS approach, which is a good starting point for learning recursion and depth first search and breadth first search, I guess. All right, that's it, guys. Thank you for watching. Bye.